It's quite a simple question. What is the perfect building? My name is Roger Mackley, and I work for a company called Hall-E. We're part of the Tetra Tech high-performance buildings group. We've been doing building services engineering since about 1862. So arguably speaking, we're probably reasonably well qualified to answer this question. Yeah, maybe. A little while ago, about a year and a half ago, I had a meeting with 8 colleagues from an organization who run a lot of buildings in the UK. And I asked them this question. And funnily enough, I ended up with 8 totally different answers. What a disaster. Now, what was interesting about these answers was a couple of things. Firstly, some of them were mutually exclusive. So I couldn't have my perfect building satisfying all of those commitments. The second thing was, of course, that because there were 8 people in the room and there were 8 different answers, that in its own right meant that all buildings will be viewed from the position of the person who's looking. Obvious, really. So the reason I want to talk about this is because of the importance. Now, I'm going to look at this from purely and simply an environmental standpoint. So I'm just one of those people looking into the building. But I wanted to put the context in. In the next 10 years, we're expected the population on the Earth to grow by 1 billion. So by 2050, we're going to, in theory, at this current rate, have another 2.5 billion people on the planet. People spend about 85% of their time in buildings. And as a consequence, buildings are responsible for about 38% of global emissions. But this gets magnified because what you also know is that 2/3 of the global population live in cities. Cities are made up of buildings, and cities consume 75% of the global resources and are responsible for 80% of global emissions. So yes, having those perfect buildings really is important, certainly when viewed from a sustainable and environmental standpoint. There are, though, these challenges. At Hall-E, we look at human-centric design and we look at planet-conscious design. And there is this tension associated with those two. Buildings are there to provide environments in which people can be productive. If we're talking about hotels, one of those metrics of productivity will be the amount of sleep you had at a hotel. If we're talking about conference centers, presumably we're not trying to get you to sleep. So therefore, we have different metrics for those different things. But because we are trying to generate that environment in a building for people to be productive, by default, we are manipulating the environment. We're using mechanical systems. We're using electrical systems. And as a consequence, we are drawing down on the resources of the planet. So there is that challenge. If you were to ask an energy manager what the best way is to reduce the amount of energy their building uses, the simple answer is very simple. Turn everything off. Okay, well, the problem with turning everything off is it means you're then undermining the reason for having the building in the first place, to generate those environmental conditions in which people can be productive. This is I think it's a fantastic building. It's in the centre of Oxford. It's the Blavatnik School of Government. As you can see, there's an awful lot of glazing. Now, as a building service engineer like myself, that gave me kittens. How on earth do you manage a building of that nature? And one of the things we did was we said, actually, you know what? We're not going to design the building to have productive environments under all weather conditions. What we're actually going to say is, when it's going to be really hot in the summer, we'll just ask people to come in flip-flops and T-shirts. Because actually, otherwise, we are going to be so against the planet side of things that it would be a bit silly. So, how do we get those perfect buildings? One of the approaches we've been looking at is this idea about the 5 capitals. This comes from a sustainability idea. And those 5 capitals, human, so we're talking about health, welfare, happiness, knowledge, social, we're talking about organizations, communities, we're talking about social networks. Talk about natural, we're looking there at biodiversity, we're looking at resource use. If we're looking at physical, we're talking about buildings, the structure of buildings, we're talking about the manufactured goods that are generated, we're talking about infrastructure. And economic, That's the services and the products that are being produced in those buildings, but it also looks at the monetary value of those other 4 capitals. And if we start to think about all of the information associated with those different metrics in those different categories, we start to understand that there's obviously a trade-off. And this is where we think indoor GIS can be really helpful. This is a photograph of our office in King's Cross. Okay, it's a pretty obvious, pretty basic office. There are walls, there are ceilings, there are roofs, floors, windows. That's all the kind of the physical stuff. But of course, what you can't see here is that you've also got the air conditioning systems, the heating, the cooling, the ventilation system, the hot water. What you also have, of course, is people going in and out of the building. And you can't see it here, but obviously there's the outside world as well. So we're now looking at a whole series of different data sets from different systems which normally are independent. But if you start to bring them all together, you can then generate actions to try to generate that perfect building. We look at the data layering. So in this case, for this office, you're saying, okay, well, where is everybody? Where are people in the office? Where have they come from and where are they going to? Because where they came from will impact the sort of environment they want to be in when they get there. Because if it's been really hot outside, they'll want the room they're going to go into to be cooler. We then obviously have the air conditioning systems, the heating, the cooling, the air quality, carbon dioxide, volatile organic compounds. You've then got the day of the week, or the day of the year, the time of the day. And that's important because we want to be able to move the blinds because we know where the sun will be. The sun is a kind of a given. You know where it is every day of the year. And we think that indoor GIS can really help with this. Jeff.
Thank you. Right, so I'm going to talk about our journey to get to what Roger's describing. So basically what we've done, you've probably heard a lot about this today. So Autodesk Esri partnership, we can now drag and drop a Revit model into GIS. We can look around it. We can click on features inside it, get back the information from that information, which is all the Revit data stored inside there, which is really good to be able to understand what's going on with that building. We can start to turn various bits of it off, so we can turn the roof off on this. We can look around, navigate around, and then we can turn the walls off and see inside the facility. So this is all really good now because what this then allows us to do is then bring that data into GIS. So with ArcGIS Indoors, we're able to import a Revit model or a CAD file plan and thematically map everything up. So this is actually looking inside Indoors. We can click on features inside it and get the same information back. It tells us if we were looking at meeting rooms. So the various colors in here, I can look at them really quickly, and I can see green as a kitchen, purple as a meeting room, which is really good. One of the other things that we can do is you get a floor plan, a floor level picker, so we can navigate really easily between the various levels inside this, allowing the user to have that full experience of easy navigation. This also looks exactly the same inside ArcGIS Online. So we've gone from ArcGIS Pro to ArcGIS Online now, and just to demonstrate the capability inside ArcGIS Online being almost exactly the same, you can see we've got the Western Transit Shed here, which is up in King's Cross. We can click on a feature inside there again and get the same information back in that kind of standard format that we get from ArcGIS Online. Being able to click on features again inside here. And then we can also, again, browse by a floor. Now, the reason I'm telling you all this is because this is where we had to start to be able to look at, right, how do we start connecting sensors to data and work out where those sensors are inside a facility. So we've created a dashboard. And one of my colleagues put this together for me to make it look a little bit prettier, so that's good. So this dashboard is showing some historic data that we've captured from the sensors. So we don't have anything like velocity yet or geo event server, but we do have lots of CSV data, so we've downloaded CSV data, ran it through some FME conversion. We were able to attach it then to the feature inside there. So we got a meeting room that we're looking at. And we could see what's going on across that meeting room back in 2019 in the month of May. So pre-COVID, lots of activity. We could see there was a big meeting that happened on one of the days. And what we'll do is we'll go ahead and look and try and investigate that a little bit more. So one of the things that's being shown here is that we've got a score that runs. So as the day goes on, the various sensors are calculating, and they're saying, yep, it's good or it's bad. But there's also an average score that's being calculated on the fly. And we can see there's a little bit of a dip on the 3rd of May, and we want to understand what's going on there. And the whole idea of the dashboards is to basically help give that insight into, there's a geographic context, we know there's a meeting room, where is that meeting room, what's the problem? So we had a big meeting happen on the 3rd, 36 people came in, and the systems couldn't cope with that amount of people all of a sudden hitting that room. So shortly after the meeting concluded, there was a dip in the score because all the calculations started coming back into the sensor. And what's interesting about this is it's trying to work out then what sensors were causing that problem. So what we can see here is we had a big spike in CO2, and we had a humongous spike in VOCs. Now, what we were able to find out and reasons why there's also this humongous spike in the VOCs is because the cleaners came in afterwards, and they started spraying off all the surfaces, and that apparently triggers a humongous VOC hit. So it's quite an interesting problem, understanding why you get a result in this, and then what that actually means. So we had to wait for a little while before the next meeting could probably take place because we wanted the VOCs to all calm back out. So the HVAC system catches up with everything, and that allows us then to plan for the future. Now, where we're going with this, and where we want to go with this, is that we become, instead of reactive, we become a bit more proactive. So we know we have a big meeting coming in. What can we do to make that room ready for when that meeting takes place so that our productivity levels can be maintained throughout the day? What are the things that need to happen? Do we need to tell the building management system that we need to crank up the AC to get the temperature down to start air circulation a little bit sooner than what we were doing previously? So that's where we're at today. This here is one of the methods that we're using to understand where people are moving through spaces right now. So this is using optical sensors inside this meeting room. So the big meeting room right in the middle there, that's the one we're going to focus on. So what you'll see here, hopefully, is that we're going to have some people coming into this meeting room shortly. And it uses optical sensors in the ceiling to actually, with machine learning, to actually recognize what a human looks like, and then scrubs the image, and then converts this to a point on the map, which we can see as people are coming into the space. Now, this is really good, but it is quite limiting technology, so we can't have a sensor every so often. And some of the things that we also have found with it is because this meeting room is so big, we've had to put 2 sensors in there. And so we get a bit of ghosting, so sometimes there's a bit of a double count on the data that's coming through. So you may see like there's a couple of people really close together all of a sudden, and they split, and then they come together. It all depends on how the sensors are reading them. That's really interesting, problem to even think about how we work that one out. So our numbers of occupancy levels, are they being misconstrued because of the way the sensors are being read? So where we want to go now is, and this is the exciting bit, is that as this technology starts to become better and better, we're looking now at, indoor positioning systems. How can we actually track the movement of people through a space and understand that? See where people are actually going to, like to congregate, or where there's nobody is. Can we use the indoor positioning systems along with indoors to direct employees to an area where there's actually better air conditions or better lighting conditions right now. So it's a different time of day. Go over to this part of the room rather than that part of the room. We also want to enable more sensors inside these facilities. So we've shown you a couple of the sensors that are in there from the air quality, but there's other sensors that we can potentially also enable that will help give us more response and information about the data and the building and the way it's being used. And then you saw a great presentation just before about velocity. I mean, this is a game changer for us, really. So being able to take the live data and stream it in this way and bring it across into the indoor environment and understand what's happening in real time allows us to have that kind of next level of being prepared, being proactive instead of reactive with building management systems, and ingesting that information from all these different sensors and getting those results. Thank you.